Assalamualaikum warahmatullahi wabarakatuh and good day. Welcome back to BQS 552 Construction Technology 4. Today we're going to learn a new chapter which is Deep Foundations. The contents of this chapter are as follows. As we know, there are two types of foundation, which are shallow foundation and deep foundation. Shallow foundations is a foundation where the transfer of load to the soil is at the level close to the lowest floor of the building. Should always be made as a priority due to economic reason. Unless it is impractical to practice, then only can deep foundation be employed. Sebab shallow foundation lebih murah, lebih ekonomi compared to deep foundation such as pile foundation. There are four types of shallow foundation, which are rough foundation, bed footing, strip footing, and cantilever footing. Next, we're going to look at deep foundation. It is a foundation where the transfer of load to the soil is at a level much below the lowest floor of a building. It is used when the ground conditions are incapable of supporting structural load, which is it is impractical to use shallow foundation at an economic depth. Jadi kita perlukan deep foundation ni bila ground condition tak mampu untuk support load yang being transferred kepada ground. The definition of pile foundation is column inserted into the ground to transmit the structural loads to a lower level of subsoil, or the foundation in which the loads are taken to a low level by means of column in the soil on which the building rests. These two definition you can pakai either these two because it is mostly the same lah. It's related to the column, which is the pile, and it transmit the load ke lowest level of subsoil. The reasons that we need to use pile foundation is because of the natural low bearing capacity of the soil, which means that tanah ni lemah. Heavy point load of the structure exceeding the soil bearing capacity of the soil. Disebabkan ada loading yang berat, tanah tu tak mampu support terlebih daripada dia punya permissible bearing capacity. That's why kita perlukan pile foundation. Next, presence of layer of highly compressible subsoil near the surface. For example, pit soil. Disebabkan tanah ada macam-macam layer, ada macam-macam jenis dan lapisan, dan ada juga tanah yang lemah. Contohnya pit soil ni, jadi dia akan lebih senang untuk compress. It's a compressible subsoil. We need the foundation untuk increase the bearing capacity of the soil. Next, we have the possibility of moisture movement and plastic failure. For example, due to clay soil. Sebab clay soil ni lebih senang untuk tanah tu mengalami plastic failure. And high water table given rise to high permanent dewatering cost. Kalau cost dewatering tinggi, kita boleh opt for pile foundation untuk at least kurangkan cost on dewatering. And then building over water or waterlogged ground. Sebab condition tanah ni memang berair, maksudnya ada area yang berair dekat tanah tu, jadi kita boleh build dengan cara gunakan pile foundation. Next, shallow foundation is impractical or costly. Maybe because bila kita pakai shallow foundation, the foundation design akan jadi lebih besar, huge, lebih besar dan berat. Jadi akan menambah lagi cost kita. Lebih baik kita pakai pile foundation instead. Or structures are located near riverbed or seabed and foundation are likely to be scarred due to action of water. That's why kita perlukan foundation sebab kita tak nak structure kita tu terhakis. Jadi kita perlukan the foundation. Seasonal shrinkage and swelling of the upper layer of soil, especially bila perubahan cuaca tu yang maybe menyebabkan shrinkage and swelling. Maksudnya tanah tu bila sejuk dia akan mengecut, bila panas dia akan mengembang. Jadi ini masalah yang sebab tu kita perlukan pile foundation. Differential settlement likely to be caused by strata changes across the earth site or by the close proximity of other structures. This is what happen because ada differential settlement. Tanah ni dia tak sama, jadi ada tempat dia akan ada settlement yang lebih lagi. The resistance of forces such as uplift or overturning which may be created by wind pressure or cantilever structure. So kita perlukan pile foundation supaya dia boleh anchor ataupun dia boleh elak the structure untuk being lifted. Jadi dia akan anchor structure tu pada ground. The resistance of lateral forces such as strata slip or other soil movement which may cause instability of the structure. And then the underpinning of existing structures. For example, this one lah underpinning. So kita nak tambah support je pada structure yang sedia ada. The selection of type, length and capacity is usually made from estimation based on the soil conditions and the magnitude of the load. In large cities where soil conditions are well known and where a large number of pile foundation has been constructed, the experience gained in the past is extremely useful. Kita boleh tengok pada adjacent building apa jenis foundation yang dipakai supaya kita boleh pakai pada bangunan yang contohnya kita baru nak bina lah. Generally, the foundation design is made on the preliminary estimated values. Before the actual construction begins, pile load tests must be conducted to verify the design values. The foundation design must revise according to the test result. The factors that govern the selection of piles are the nature and the type of structure. Mungkin kita nak bina bangunan ataupun kita nak bina bridge, wharf, jetty dan lain-lain structure. The location di kawasan bandar, di kawasan suburban ataupun kawasan luar bandar. Ataupun mungkin di kawasan yang berair, contohnya macam dekat paya, sungai. Material, equipment and fund availability, type of soil and its properties. So we must know actually subsoil jenis apa and then whether there is a hard rock strata dekat below the bottom level of the subsoil. Next, groundwater table. So we must know whether the groundwater table is high or not because certain piles tak boleh pakai kalau ada existing groundwater dekat dalam tanah. Durability of piles, length and number of piles, the case study of the adjacent building, facility for pile driving. Jenis apa you nak pile drive ni, you nak pakai jenis apa, whether you pakai vibration, you pakai hammer. So it depends on the machinery. Erosion of soil near structure. So kita kena tengok juga soil stability yang berada dekat kawasan structure yang kita nak bina tu. We can classify the piles based on the function, materials and method of installation. There are 8 types of pile when we classify it based on function. End bearing pile, friction pile, compaction pile, tension pile, anchor pile, fender pile, butter pile, and sheet pile. End-bearing pile penetrates through the soft soil. The bottom of the tips will rest on the hard strata of the soil. It is used on the site where the firm bearing stratum can be reached by the piles, sometimes at the depth of 45 meter or more. Jadi dekat dalam tanah ni ada layer yang tanahnya keras lah, which is the hard strata. Derive the greater part of their support from bearing forces at the base. They act largely as column, transferring load through the soft deposit, usually to relatively firm soil such as rock, very dense sand or gravel. Jadi dekat menggunakan end-bearing pile ni, structure punya load akan ditransfer pada pile ni yang act macam column yang akan ditransfer kepada hard strata. The load of the structure is transmitted through the pile into this firm soil because the base of the pile bears the load of the structure. This type of pile is known as end-bearing pile. Next type of pile based on function is friction pile. Piles are driven at depth when friction resistance develops equal to load. It is used where there is no reasonable bearing stratum and they rely on the resistance from skin of the pile against the soil. Jadi the skin ni maksudnya surface of the pile lah. Friction surface of the pile dengan soil tu. Total friction resistance can be increased through increasing the length and diameter of the pile, making pile surface rough, placing closely or grouping of pile. Jadi kita boleh letak pile tu dalam group ataupun kita boleh besarkan diameter dan panjangkan dia, and also skin of the pile tu kita kasarkan, jadi the resistance dia akan semakin naik lah. The pile transmit the load of the structure to the penetrable soil by means of skin friction or cohesion between the soil and the embedded surface of the pile. It works best in silty, clayey and sand soil. Next is compaction pile. It does not carry any load. It created purposely to create the bearing capacity of the soil. Jadi pile ni tak ada transfer load pun daripada structure tu kepada tanah. Cumanya dia hanyalah menambah bearing capacity of soil. Maksudnya bila kita masukkan pile tu, tanah tu akan semakin compact lah. Jadi bearing capacity of soil akan semakin naik. Tension pile. When structure subjected to uplift due to hydrostatic pressure or overturning moment. It is also known as uplift pile. So tension pile ni dia function dia adalah untuk mengelakkan daripada your structure yang you build ni overturn ataupun ternaiklah, uplifting. Jadi kita pakai this tension pile actually untuk anchor this structure to the ground. For anchor pile, it provides anchorage against the horizontal pull from sheet pulling or any other pulling. Different daripada tension pile. Tension pile lebih kepada moment yang akan overturn the pile. This one, the force tu adalah horizontal. Jadi this pile anchor the structure supaya structure tu tak fail horizontally. Next, we have fender pile. It used to protect waterfront structure against the impact from ship or other floating object. So normally fender pile ni tak support any load. It's just that letak dekat, for example here we have macam bridge. Fender pile ni nak protect this bridge daripada contohnya impact kalau ada ship terlanggar pada this bridge. Next we have the butter pile. Butter pile ni sebab kalau you tengok dia sengit, that's why nama dia butter pile. Dia lebih kepada incline lah dia punya position . It is used to resist large horizontal forces or inclined forces. Next, we have sheet pile. It is used as bulkhead or as impervious cut-off to reduce seepage and uplift under hydraulic structures. The sheet piles can be classified to concrete, steel and timber. Next classification of piles we have based on pile material. First we have concrete, steel, timber, composite ataupun sand pile. Concrete pile consists of precast, cast in situ or pre-stressed concrete pile. Concrete pile can be selected for foundation construction under the following circumstances. The need to support heavy loads in maritime area where steel piles easily corroded. So kalau pakai materials contohnya seperti steel, dia lebih senang terhakis. Jadi kita boleh opt untuk guna concrete. Existence of stronger soil types located at nearly shallow depth that are accessible to concrete piles. Design of bridge piers and caissons that require large diameter piles. Design of large pile groups is needed to support heavy extensive structures so that the total expense can be minimized. The need for mini piles to support residential building on weak and compressible soils. Precast concrete pile, it can be manufactured in factory or at a place away from construction site. The method of installation can be driven, pushed, vibrated or screwed into the ground. This type of pile is commonly used where the length required can be realistically predicted. Lateral pressure from a stratum within the soil profile is sufficient to squeeze a cast in situ pile. Jadi cast in situ ni tak sesuai untuk kita pakai, kita boleh opt for precast concrete pile. Where there are large voids in section of the soil which would possibly have to be filled with an excessive amount of in situ concrete or could cause loss of support for wet concrete prior to setting. For structures such as piers and jetties above water level on coastal, estuary and river side. The typical shape for precast concrete piles are square, octagonal or round in section. Generally, square section is commonly used. These are used on medium to large contracts where soft soil overlying a firm strata are encountered. Length up to 18 meter with section size ranging from 200 mm times 200 mm to 450 times 450 mm. So ini adalah size yang common for square pile. Normally for precast concrete piles, the installation will use the percussion driven using a drop or single acting hammer. Ini adalah precast concrete pile dan you have a crane here and there is hammer on top here yang akan hammer down the pile to the ground. Next we have the cast in situ concrete pile. A bore is dug into the ground by inserting a casing. Bore is filled with cement, concrete after placing reinforcement. Jadi borehole ni akan diletakkan reinforcement dan kemudian akan di-pour concrete lah inside. The casing be kept in position or it may be withdrawn. Maybe casing ni dibiarkan saja ataupun mungkin kita akan keluarkan, jadi tak ada casing lah. The piles with casing are known as case cast in situ concrete pile, and the pile without casing are known as uncased in situ concrete pile. Next, we have pre-stressed pile. This pile can be used for the foundation of all types of engineering structures under nearly every soil condition. The advantage they offer are their strength in bearing and bending, their durability, and their economy. Pre-stressed concrete pile in superstructure design is made of higher strength concrete. It requires smaller cross-sectional area and can be made impact resistant. The same result apply to pre-stressed piles relative to comparison with the precast reinforced piles. Jadi kalau kita ada pre-stressed piles and precast reinforced piles, pre-stressed piles normally size dia akan lebih kecil, tapi the strength akan sama macam precast reinforced piles. Next material classification is steel piles. Steel preformed piles can be formed in a wide variety of sections and can be adapted to suit almost any ground condition. The common profile used for steel piles, we have H piles, box, and tube piles. This is H pile, bentuk H huruf H. This is box pile, and this is tube or pipe pile. Steel pile can be lengthened or shortened if required during driving. Where soil conditions are problematical, the steel may be specified in one or more of the following ways. To be high yield steel, to have protective coatings, to be heavier section than would otherwise be needed when the outer surface is considered to be sacrificial depending on durability requirements. Corrosion conditions in the marine environment can be severe and steel piles are normally grit blasted before coating. For example, we can coat using the epoxy formulation. So grit blasting ni normally kita akan pakai any abrasive medium lah. Okay, kita akan blast menggunakan contohnya compressed air kepada surface of the pile. Mungkin untuk sama ada kita nak mengkasarkan the surface ataupun sebenarnya kita nak menghaluskan surface yang kasar. Jadi kita boleh pakai this grit blast. H piles have the wide flange section suitable for trestle type structure in which pile extend above the ground level and can act as column. Jadi pile ni sendiri yang boleh dijadikan sebagai column kepada structure you. Have small cross section area, therefore can be easily driven into soil. Used as long pile with high bearing capacity. H pile or universal steel beams are being increasingly used as bearing piles. The length can be up to 36 meters with various section sizes. The pile can be driven by any type of hammer or vibrator, but must suit the angle of driving when driven on the rake. Pile may be supplied coated with various form of protective paint. Sebab ini adalah steel, jadi dia prone pada corrosion. Kena letak layer of protective paint. This is the example of H pile. So H pile ni sebenarnya kita ambil daripada steel beams. Dia akan boleh jadi H piles. For box piles, the shape are rectangular or octagonal. Box pile can be formed by welding or riveting sheet piles together or by producing purpose-made section. Tadi H pile ni sebenarnya kita boleh guna daripada sheet piles yang memang ada, kita boleh sambungkan dan bentuk dia menjadi box piles. Ataupun boleh juga diproduce daripada factory yang memang ikut sizing yang kita nak lah. The length up to 36 meter with various section size. They will inform filled with concrete. Jadi boleh juga bila being driven into the ground, kita boleh fill dengan concrete. So dia akan jadi macam composite pile. These piles are used when not possible to drive H piles into hard strata. Disebabkan dekat sini mungkin ada lubang jadi dia lebih senang untuk drive compared to H piles. Kalau H piles mungkin akan bengkok lah sebab dia ada web dengan flange area dia mungkin nipis ataupun mungkin lagi prone untuk bengkok compared to this type of box pile. This is the example of box pile. We have the Z box pile, W box pile, triple U box pile and quadruple U box pile. Next type of steel pile, we have tube piles. Tube piles of steel are driven into ground. It is used because of the circular cross-section. Tubes are easy to be driven in. Typically, the piles are 6 meter long, although 3 meter segmental pile can be used where the access and the headroom is restricted. Jadi kalau headroom tak cukup, kita boleh pakai yang lebih pendek punya segmental tube piles. Particularly suitable for driving in difficult or uncertain ground condition up to 50 meter deep. Tube piles are available in many sizes from 125 mm to 350 mm diameter with a range of thickness. Jadi tube piles ni ada macam-macam jenis. Kita pun panggil juga tube piles ni as pipe piles. Sama je. Tube piles are normally driven with an open end so that soft fills and plugs the void. Open end tu maksudnya hujung bawah tu sekali memang kosong lah, kita tak tutup dia, jadi dia tanah tu akan masuk dalam lubang tube tu. Suitable to be driven by hydraulic hammer. Tube piles are a good candidate for butter pile. So kita dah tahu tadi butter pile tu yang mana, yang incline, yang sengit punya pile tu. Jadi tube pile kita boleh guna for the purpose of butter pile. Tube piles are cheaper than steel H piles or concrete piles. This is the procedure for installation untuk open end tube piles. When it is driven, the soil inside the pile is removed by water jet. Kita boleh buang tanah dalam ni dengan menggunakan water jet lah. Open end pipe piles are easier to drive through hard soils than closed end pipe piles. Sebab ada juga jenis kita boleh tutup bawah pipe pile ni ataupun tube pile ni This is the example for closed end tube pile. Okay, kalau you nampak kat sini, ini contoh tube pile lah. Kat bawah ni kita letak steel plate so that belah bawah tu akan tertutup. Kita welding lah for the connection In exceptional circumstances, the end of the pile can be closed by welding and end plate. The void at the top of the pile is filled with concrete. Kalau ada keperluan, kita nak guna juga masukkan concrete dalam lubang tube pile tu. Reinforcement can be positioned in the pile, allowing it to be tied into the pile caps reinforcement cage. Jadi kita boleh letakkan reinforcement sebelum kita concrete pile tu supaya nanti reinforcement daripada pile tu kita boleh connect kepada pile cap. Timber, it is prepared from trunks of trees. It may be circular or square. Diameter of piles are 30 to 50 cm and the length not exceeding 20 times of its top width. At bottom of cast iron shoes is provided and atop a steel plate is fixed untuk protect dia supaya dia tak pecah lah. Kita akan pakaikan dia cast iron shoe and juga letak steel plate supaya kita dapat protect the top masa kita hammer down the timber piles. Timber is a relatively inexpensive material to be used in construction, and its durability against rotting can be improved using preservative and advanced techniques such as that are available in the market. However, main drawback of timber piles is the limited structural capacity and length. Hence, timber piles are most suitable for construction of residential buildings in marshy areas and for stabilization of slopes. So this is the example Ini adalah pile shoe yang kita pakaikan pada timber piles. Sebab kita nak elakkan dia split terpecah due to the impact. For example, kalau kita drive using hammer. The pile is guided by a pile frame and percussion driven by standard equipment such as drop hammer, which should be equal in weight to the pile being driven for hard condition or half the pile weight in the soft condition. Alternatively, low capacity air or hydraulic hammer may be employed. For the permanent timber piles, it should be cut off and capped with a reinforced concrete pile cap. Pile materials, we have composite piles. Piles of two different materials are driven one over the other. It acts together to perform the function of single pile. Jadi ada dua material yang berlainan yang kita gabungkan untuk act as single pile. Advantages is taken of durability of concrete and the cheapest of timber pile. For example, kalau kita combine antara concrete piles dan timber piles. Timber piles is terminated just at the level of the groundwater table. Jadi bila ada exposure pada groundwater table, kita akan stop timber piles dekat that level so that concrete piles yang akan kita sambungkan pada timber piles ni, sebab timber piles dia lebih senang rot bila ada exposure to the water. The other type of composite piles, we can combine pipe or tube pile with timber pile. It is well known that timber pile will decay above groundwater. For this reason, steel or concrete tube piles are used above groundwater level. Okay, ini cara macam mana kita construct this type of pile. The first step is kita akan drive the pile below the groundwater level. And then kita akan drive the timber pile inside the steel of the concrete pile. Sebab ada hole dekat tengah ni yang kita boleh drive the timber pile. Concrete the annulus between the pipe pile and the timber pile. Next step kita akan concrete lah bahagian dalam pile ni. Yang lubang ni Next combination of the composite piles are precast concrete piles with H section. The precast concrete piles are not economical for length more than 60 feet. For this reason, an H section is attached at the end. Jadi bila terlampau tinggi, pile yang kita perlukan, dia jadi tidak ekonomi kalau kita rely on the precast concrete type. Kita akan combinekan H section untuk menambah the length of the pile. Further, H section are very capable of penetrating hard soft strata and boulders. Skin friction is much larger in the concrete section due to larger diameter. Okay, walau macam mana pun concrete section ni skin friction dia lebih tinggi lah disebabkan diameter dia yang lebih besar compared to the H section The last material for pile is sand pile. It is formed by making hole in the ground and fill with sand and well rammed. Jadi akan kita compact dia lah. The sand should be moist at the time of the placing and the top of the sand is filled with concrete. Sand piles are placed at 2 to 3 meter spacing between each other. Load tests must be carried out to determine the bearing capacity of the sand pile. Properly compacted sand pile can carry load up to 100 ton per meter square or even more. How it is constructed? We first need to set the casing pipe to the predetermined place. Contohnya macam ini, dia letakkan dekat kat mana yang kita nak lah, the point By operating the force, lifting or driving device, install the casing pipe into the ground while rotating. Jadi casing ni akan kita drive ke dalam tanah dengan cara dia berpusing lah. Biasanya casing ni adalah tube, jenis tube ataupun pipe The sand is fed through upper hopper after the pipe has reached the required depth. After pipe ataupun tube ni dah sampai ke kedalaman yang kita nak, kita akan fed sand ke dalam tanah tu. Casing pipe is pulled out, which result in the sand being pressed out to the void by compressed air. Jadi kita akan keluarkan balik casing tu dan tanah yang sand yang kita masukkan tadi akan mengisi void dalam tanah tu dengan cara compressed air. The casing is then extracted along with the compaction of the pressed out sand pile so as to enlarge it. Jadi bila ada that compressed air, casing tu being extracted out, jadi dia akan fill in the void dan sand pile tu akan tercompact lah dekat dalam tanah. Above procedure is repeated until the sand pile are formed to the ground surface. Sehingga sampai ground surface, kita akan repeat this procedure. Thank you for your attention. I will end the recorded video with a quote from Pelé, which is the Brazilian pro footballer. Success is no accident, it is hard work, perseverance, learning, studying, sacrifice, and most of all, love of what you are doing or learning to do. Okay, thank you so much and bye. Assalamualaikum.